saw how we can add two vectors together, P plus Q, R plus P. Then we need to make a connection with this vector, column vectors. In example 8, vectors A and B actually can be expressed as this. Look at your previous page, A and B. Is it example 8 or try 8? In example 8, okay. Here we say that vector A can be represented by a column vector. What is the column vector for vector A? By now, all should be experts at it already. No room for error. Along the x-axis, are we going from the start to the end? From the start to the end, are we going in the positive direction of x or negative direction? From the start to the end, are we going in the positive or negative direction of x? From here, we're going this side, right? Then we go this side, yes? Yes. Okay, so positive or negative? The first one. Positive direction of x.
Cannot go from that side.
Why cannot go from where?
Okay, never mind. It's okay.
No. Do you get it or not?
Yeah, I need to go from the start.
Yeah, we need to start from the beginning. So this will be 1. And then how many units downwards? Negative 3. Okay, very good. What about B? What is the vector, column vector for B?
Negative 2 and negative 2.
Okay, what about for C?
Negative 3 and 1.
3 and 1. Okay, very good. Then A plus B, vector A plus B. Yesterday we did this, A plus B. Okay, I am going to copy B. Home, draw, that's all. Okay. So this was what I did, A plus B. This being my vector B. Thanks for switching on the fan for me.
No problem, sir.
You say one, I want my letters tomorrow. Okay, so this is A plus B. So the resultant vector looks like this. From here to here. This is my resultant. In blue color, A plus B. All agree?
Yeah.
Okay, then we can see that we can use these column vectors to help us arrive at the same answer. What do we have if we take A plus B in the column vector form? So 1, negative 3, that is A, plus negative 2, negative 2, that is B. Then if you do your matrix addition, like I said, your column vectors can be considered as matrices. What is the answer? Negative 1? Negative 5. Okay, so let us verify our answer. This is our start. Then we go along A, then we go to B, this is our end. So effectively we are traveling this blue line, right? This blue arrow. How many units to the left do we have?
Negative
1 unit to the left, so that is negative 1. How many units downwards? 2, 3, 4, 5. Negative 5. So you see, we can actually solve it without drawing, as long as I express them in column vectors. Is that easier?
Yeah.
Okay. So this is the summary of what we have just said. That is found on page 169. Basically, when we have vectors like this, x1, y1, there is a reason why they use x and y, because I've repeated many times, the number at the top refers to the magnitude, should I say magnitude, the displacement in the x-axis direction, whether it is positive or negative. It will refer to the direction along the x-axis, left or right. The number at the bottom refers to up or down, okay? That is why they have a y coordinate, and adding them up will simply give us this. it works with subtraction also. Okay, so I will use this example, class activity 1. Here I have a parallelogram A, B, C, D. Parallelogram is just a shape. When I give a direction, for example AB with this arrow over here, that makes the line segment become a vector. So initially we only have AB. AB is just a line segment, it is not a vector. But the moment I draw an arrow at the top, it becomes a vector starting from A going to B. And this vector we call it U. Okay, that is given in the question. Then AD is B. Draw the sum of AB plus BC in the diagram. This is AB, then BC. BC going this way. Right? So here I have my start. And I have my end over here. So what does AB plus BC look like? Just one diagonal. This is known as AB plus BC. And in summary, what is it called? AC law. Understand?
How do you know if the arrow is going that side?
Because you started from here.
So the direction.
Yeah, where you start doesn't change. So from the start you went to B, then after that B you went to C. You started from A, you still remain starting at A. You ended at C, so you will still end at C. So the resultant vector looks like this. Okay? So draw the sum. This is my AB plus BC. That is for A part 1. Part 2, represent AB plus BC using a single vector. So this will be AC. Okay, because B is intermediate, right? The intermediate point, and they are the same. So I say that once the intermediate points are the same, the resultant is simply A and C over here. Okay, yeah. Next, express AB plus BC in terms of U and V. Not quite easy, huh? AB plus BC must be equal to U plus V. This is the first instance where students will miss out on the worms. So they'll leave it like this. Then when I see the paper, I'll say, oh, these are scalars, they are not vectors. Wrong. Okay? Because this is a topic on vectors. The moment you use scalars instead of vectors, you'll be wrong. So you need to write down, you need to draw your worms at the bottom. Okay, next part. Part B. Draw the sum of AD plus DC. AD, I will use another, let's erase all this. AD plus DC. So where do we start from? A. Where are we ending at? C. Okay, draw. This will be our resultant. AD plus DC, which is simplified to become AC. Simple? Okay. Express it in terms of U and V. Okay, now, can you tell me the answer? AD Okay, AD plus DC. AD was V plus U, right? Because this part is also U. Am I right? Okay, so this is equals to AC. Earlier on in part A, we've got AC as well. If you remember, we said that AC was equals to U plus V. Then now we have the same AC, but it is V plus U. Are they the same thing? Yeah, they are the same thing. Which is why it makes it so easy for vectors. It is as though they are just scalars. Our algebra, A plus B. Isn't it the same as B plus A? Right? X plus Y is the same as Y plus X. Same thing. When I change them to vectors, they still function the same way. Alright? So that is the relationship. Then I shall not bore you with the rest. This is our summary over here.
So after it just
This is the summary.
What's the work?
Very logical, isn't it? U plus V is V plus U. Then U plus V plus W is the same as U plus V plus W. Where you put the brackets doesn't matter because we are adding them up, right? Change them all to our usual standard algebra. This totally makes sense. It works the same in vectors. Alright? So don't need to confuse yourself over this. It just works the same way. So let's look at example number 9. So we see how easy vectors can be if you understand them properly. I've got A, B, C, E is a rectangle. AB plus AE plus CD. Okay? As a single vector. So let's trace it out. AB is over here. This is the start. It is a good practice to use a pencil and trace it out. Okay, start A to B. Then where do I go from B? I'm supposed to add AE. AE is over here. How? Can I just move this vector over to this side? I can. It's the same vector. How do you know they are the same vector?
It's a square. It's a rectangle.
So what if it is a rectangle? Do they have the same magnitude, the two sides?
Yeah.
Same magnitude, right? Do they have the same direction?
Yeah.
Then it's the same vector already.
But they never put what direction.
Yeah, you're right. They didn't put direction. But over here, they've got direction, right, for AE. Then over here, they wanted if I were to stop at B, if I go from B to C, isn't it the same direction? So we say that BC is actually the same as AE. Am I right? Same direction, same magnitude. So yeah, they are the same. So AB plus AE, this one, let me rewrite it. This is the same as AB plus, instead of AE, I'm going to replace it with BC. Because AE and BC are the same. Okay so far? So now from A, I move to B, I move to C. What is the last one? Plus CD. I'm very happy to see CD. It is from here to here. So this is my N. I got my start and my end. So this is now written as a single vector starting from A to, where is the ending? D. So this is my final answer. This is the same as AD. Okay? No need to bother yourself with what parallelogram law, triangle law. The names are not important. As long as you know how to shift the vectors around. Know which vectors are equivalent. Can? Try it yourself. 9. Just move the vectors around. See which one are. If it helps, you may look up. We start with, this is the starting point. Start. So Q over here. It's my start. I want to travel to P. So I go on to P. So I end here. Next, I want R, QR. But we see that QR looks like this. Right? It is the same as PS. Yeah, I can actually. No, I'll prove to you all that they're the same. Okay, so I can move it over here. Okay, so this is the same as QR, right? Okay, so this is all equivalent to QP plus PS, right? QR and PS are the same. So now I'm here already. So next one, SR, S to R. N over here, plus SR. So this is my N. This is my start over here. Start and end. So our final answer must therefore be QR. So this is equals to QR. Okay? Then we can actually do all this without drawing. Because I see that from here, QP plus PS, this P and P are the same. Cancel them out. S and S are the same. Cancel them out. Then I'm left with QR. That's it. Okay? Because all the intermediate points, not important. Okay? Okay, now we are going to try with magnitude. So example 10, angle between two forces. Okay, the forces are OA and OB. The magnitude of the line corresponds to the magnitude of the force. And there's an angle of 60 degrees between them. The magnitude of OA is 12 newtons, so that's why they have a 12 over here, and they have these two strokes over here to represent the magnitude. Now this is 8. Find the magnitude of the resultant force. Okay, to find the magnitude of the resultant force, we first need to find the resultant vector. What does the resultant vector look like when we add? Because I have two forces acting on the same point. At the point O, I have a force moving to the right, that is force with 12 newtons, and another force B, 8 newtons. What is the resultant force like? How do we draw the resultant force? When you add these two up. Center? Where's center where? Here. You mean with 30 degrees? 30 degrees. So here 30 degrees, here 30 degrees, is it? And then until where? What is the magnitude? Huh? 12 plus 8 ah? Draw, what do you mean draw same? You mean like that, is it? Are you saying draw a parallelogram? Oh, okay, draw a parallelogram, yeah, that works. Wait, Sophia asked why is it 30 and 30?
Yeah, but you don't know if it's equal or not.
Junior can answer why is it 30 degrees? What's wrong with this? Cut into half ah? Cut into half? Yes? No? How about if I exaggerate? No. What is going through some of your minds will be, does the diagonal of a parallelogram bisect the angle? That should be what's going through your mind. And we're going to find out with a sketch. And I'll exaggerate my parallelogram like this. Okay, this is a parallelogram. So I'm going to draw it this way. With this exaggeration, is it very clear that it doesn't bisect already? Right? So can you say for sure that it is 30 and 30? Cannot. So that is one mistake. But generally, the other thing he said was that to draw a parallelogram is correct. This is the parallelogram law of vector addition, which I said, name doesn't matter as long as you know how to do it. So this over here will also be 8. This over here will be 12. When we add these two up, your 8 and 12, this is our resultant force. Okay, so by right, we should have this in dotted lines. Because these forces do not exist. We are introducing them to help in our calculation. Okay? Alternatively, this is what you can also do. Your 6 plus 8, we draw it this way. Your 8 plus 12. So this is O, this is A, 12 over here. Then I add the vector OB. I just shift this vector over to this side. Okay, so my resultant is now going to be this. What I'm highlighting now are the same. You have two methods to choose from, parallelogram or triangle. Just know which is more convenient for you in whichever instance. So now that I know the resultant is the highlighted yellow one, I need the question required the magnitude, right? So what's the magnitude of this angle? If it is a scale drawing, I can simply measure and convert, but it is not. So how?
That one is 8, right?
Yeah, this one over here is 8, yes. So how to find the magnitude of this yellow line?
Sine rule.
Sine rule? Cosine rule? Which one?
Cosine rule.
Cosine rule. Okay. So let us call this let's call this x. So what is the magnitude of x? magnitude of x equals to what? You're saying cosine rule, right? How?
But the angle is 30 degrees.
The angle is what? Which angle? Which angle are you referring to?
The O.
No, you mean this one?
Yeah.
That is not 60.
30.
Just now you asked me whether it's 30 or not, and then we say it's not 30 already, what? Then how? How to find out?
Use the 60 or just like OAB.
OAB? O, wait, what?
Angle A.
Oh, angle A. This angle is it?
Oh, 180 minus 60.
Oh,
then
yeah,
it's
yeah, 180 minus 60, right? So this is 120. So it is over here 120 also, right?
And then cosine rule.
Now we can use our cosine rule. So the magnitude of x will be,
A square
okay, this square equals to
B square.
12 square plus 8 square minus 2 times 12 times 8 cosine 120 degrees. So to find this magnitude, all we need to do is to square root everything. Can? Cosine rule will be tested in chapter for vectors. Confirm. Okay, so this is what we had. Here, cosine rule.
In the formula. Yeah. Cosine rule.
Oh,
Huh?
okay, so the magnitude is obviously positive.
Huh?
We can also find the direction if we want to in the form of bearing if it is given to us. Okay, so your homework today is try 10.